Alright, worksheet 2, numbers 1 through 4, where we're going to give all reasons why the graph is not continuous at the given value of x. So what we're looking for is, there's 3 criteria for a function to be continuous, and we're looking for which one of those is not met. Okay, so at number 1, at x equals 4, we go up and there's an open circle there, that's a removable discontinuity, so there's no value. So you can write no value, or you can write f of 4 does not exist. Something, either one of those is fine. Okay. At x equals 2 here, there is a value. Okay, the value is this closed circle, and there is a limit of the function. The problem is that they're not equal. So you could just write f of 2 does not equal limit of f of x as x approaches 2. Right? Number 3. Here we've got different left and right limits, so there's no limit. We can just write no limit. Or you could say limit as x approaches 2 of f of x does not exist. And these are all or. You can do one. You don't have to say all of these things. You can just say one or the other. Either just saying no limit is fine, or you can say limit of f of x as x approaches 2 does not exist. Again, number 4, we have here asymptotes. The limits are not equal. The left and right limits are not equal, so there's no limit. Okay. There's 1 through 4. Alright, number 5 is a piecewise function. We're given 2 different rules for the same function, so I'm going to plug these into the calculator. And so I'll plug in the first rule in y1, and it's going to be negative 0.5x squared plus 4. And then I'm going to put parentheses around the whole thing. Oops. Insert parentheses negative. Get rid of my negative there. And I'm going to divide by the domain in parentheses. So x is greater than, second test, the test menu there, and greater than or equal to 2. Okay, and the next one is just x minus 5. And again, parentheses around the whole thing. And we'll say divide by x is less than 2. So when I graph that, okay, that function right there looks kind of like that graph from number 3, a little bit different, but we get this parabola. So let's see, let's graph this, and obviously the rule changes at 2. The first function is just x minus 5, so I'm just going to go down 1, 2, 3, 4, 5. Okay, and that's got a slope of 1. So I can just draw up until 2. 2 minus 5 is negative 3. So that's going to go right there. And that one's actually going to be our open circle too, which I'll put in there in a minute, because this is the rule for less than 2, not less than or equal to. So I'm going to make this an open circle. The next one is a parabola, and let's trace y1 at 2, and we get 2. So we're going to start this one up here with a closed circle at 2. If we plug in 3, let's plug in 3, and we get negative 0.5. And here, if we plug in 4, we get negative 4. So it's going down like that. That's not very good. It's a parabola that goes down here like this. Doesn't have to be fancy. Okay, the limit as x approaches 2 from the left, coming up this way, looks like negative 3, right? And the limit as x approaches 2 from the right, coming in this way, is positive 2. Okay, there's number 5. Now we have that same function in number 6, and what we want to do is find a value of k which makes this function continuous at 2. So what we're going to do is take the two rules and set them equal to each other. Negative 0.5 x squared plus k equals x minus 5. And we know we want this to be, we want it to happen at x equals 2, so we're going to plug in 2, negative 0.5 times 2 squared plus k equals 2 minus 5. So 2 squared is 4, half of 4 is 2, and it's negative. So negative 2 plus k equals, and 2 minus 5 is negative 3. So then we're going to add 2 to both sides to get k by itself, so k equals negative 1. Okay, you can check this, and the great thing about this is I've already got this in my calculator. I can just go in and k was replaced that 4, so I'm going to go over to the 4 and replace it with minus 1. And if I graph that, it should look a little bit different, and they meet up.